Okay. Yeah. Saman was asking around within our group at CSAIL. Do you know any wizards of using AI coding tools who can come illuminate for those of us in academia the best practices of today? And I immediately thought of Thomas, who I'm very glad to introduce now. His bio slide will contain some duplication of what I'm saying here, but to condense it, I think of him as having a really interesting background at the intersection of compilers, low-level implementation, and functional programming. And we've been very glad to have him on the team at Nectree, a startup that I co-founded based on research at MIT, which is based on, in a really quick version, designing a new programming language, which happens to be a great fit for LLM code generation, where we want to adopt some of the standard best practices of AI coding tools while also taking advantage of what's distinctive about this language. So it was Thomas's job to figure out the best way to connect that mainstream cutting edge with our stuff. And he did an amazing job adding some fundamental new capabilities that make our product so much more usable than it was before. We can actually just put it in front of people, and it usually works today, which was very much not the case before he got involved. And not only did he lead the architecture of the AI coding agent part of our platform, but he also brought in an approach to our own internal development, basically becoming a kind of coach to the engineers in the company about the best way to take advantage of this new breed of coding tools, Claude Code, etc. And now, the rest of you on this call are lucky enough to get a little bit of coaching yourself, and I'm very glad to turn over to Thomas for the rest.
Yeah, thanks, Adam. Uh, I did just share my screen recently before, but I'm going to do it again if I can find where it is. It's right there. All right. And then we are full screen. We're good to go? Great.
This looks great, yeah.
Cool. All right. Thanks for the intro. Today I'm going to talk about slop being a skill issue. And I'm sure everybody's heard the word slop. This basically just means the junk that AI tools produce when you're trying to use them and make your code base better or move faster. But somehow you're moving slower. And my assertion here is this is actually a skill issue. It's not a problem with the models. You're just using the tools wrong. So this talk is, subheading being the engineering around AI agents. So there is a little bit of engineering you need to do. I'm going to talk about all those things. It's not coding per se, it's not software engineering, but it is this term context engineering. And so that's going to be the biggest premise of this talk is context engineering. I'm going to teach you all about it and how you can make these tools work for you. So very briefly, I'm going to talk about who I am because Adam did a great job. I'm an AI engineer at Mercury Technologies. I work on the background agents for the entire engineering org. These are like agents in the cloud that do work on tasks that engineers don't want to assign their entire context window or their entire focus to. Previously, I was at Nectree with Adam. I did some of the things that that Adam said. The biggest one being developing the Nectree product agent. And then in my past career history, I've been a Haskell enthusiast, a little bit of a like industry proponent for using functional programming in industry. And I've been working on compilers. And as of late, I am working on agentic engineering. Apparently, that's a new discipline, after the past 6 months and all the improvements we've made to the models. Okay, I can't use arrow keys. At least I can. All right, so I'm not afraid of AI taking our jobs. I'm afraid of the slop that people have the capability to produce with them. I'm a little bit worried for the next few years about the damage that we can do to our code bases if we're not using these tools correctly. Software engineering best practices are more important today now than they ever were because of the rate of speed at which we can generate code, right? We're producing so much code that the code quality better be good or else we will all lose our way, agents and humans alike. So there's this notion of the ZL continuum in the, X or Twitter zeitgeist, which is basically like, do you read all the code that's produced by the AI agents or do you just kind of wing it and YOLO? And Obviously, it kind of varies per task, but I'm going to argue in this talk that we all should be reading all of the code all the time. And anybody who's a proponent of like just letting the AI do whatever it wants is in for a rough awakening in the next, 3, 6, 12 months, however long. So this kind of all kicks off with a talk that was given at AI Engineer World Fair last year, where a researcher at Stanford actually tried to quantify the productivity gains that people are seeing from these AI tools. Now, this was, 12 to 18 months ago. So some of the data here is a little bit outdated. But basically what Igor did is he took 100K devs across all company sizes. Most of them were in software engineering leads to doing like kind of reworking of code bases. And he found that, oh, sorry, most AI usage in software engineering leads to rework. Sorry about that. And this means that they kind of at the current state largely suck for brownfield or complex tasks. This is what he found. So he actually quantified it quite well and said that, okay, yeah, we are shipping faster, but most of the extra stuff we're shipping is just reworks. It's just rewriting the slop that we produced last week. So you might feel like you're being more productive, but quantifiably, we're not really quite seeing the gains that the frontier model providers assert that we should be seeing based on the models that they're delivering to us via tools like Claude Code or Cowork, or sorry, or Codex. We're seeing a lot of benefit in greenfield, low complexity tasks, but not so much benefit in brownfield, high complexity tasks. He quantified it to say between 0 and 10% productivity improvement, which is pretty low. Now, again, this is about a year, 15 months old. There's been some boosts in model efficacy and capabilities in the past 6 months in particular. So you can bump all these percentages a little bit, but we're not seeing 4, 5, 10x gains that people are talking about. The general sentiment you might find in some of your circles is that, these models produce too much slop. They're a tech debt factory. They don't work well in big repos. They don't work for complex systems. And somebody might say, well, okay, we're not there yet, but maybe someday when the models get better, we can get these productivity gains that these frontier model providers are promising. So, with that said, I have spent the last 6 months building AI agents, which doesn't sound like a very long time, but in our industry, that is basically half of the time that humanity has had agents. Now, okay, if you can go back maybe 2 years and say, okay, there's that. The notion of an agent was being around, but I'll define agent in a second, and that definition hasn't existed for larger than 9 or 12 months, right? So I've been focusing most of my time understanding these tools and how we can get them to work for us. The first thing we need to talk about is context engineering. And in fact, this will be the majority of the talk today. And this is, if you take anything from this talk today, it's that you need to be a context engineer. This is how you're going to get the most out of these tools. What context engineering means is it means to control the information that is injected into the context window. Now, this is not a talk about how LLMs work. I hope that all of you understand what a context window is. In very brief, it is the number of tokens that you can fit into the working memory of these LLMs before they need to start over, right? Before they need to kind of wipe everything clean and start from scratch. So this is the amount of information they can attend to at once. Context engineering means getting the most out of today's models. So if you want to make these tools do better at the things you want them to work on, you need to be a context engineer. Context engineering is basically everything. It's, if you've heard of RAG before, prompt engineering or memory systems, or, how we maintain state and conversation history, structured outputs, basically everything that is with respect to, or everything that is regarding putting information into the context window of the LLM. Doing that intentionally is engineering the context, right? This is the foundation of using these tools correctly. We also mentioned the term agent. So what is an agent? An agent is it a person, a microservice, a chatbot? It's had a lot of definitions over the past year or two. And I'm going to tell you today that an agent is the model plus the harness. Okay, well, what is the harness? The harness is everything that's not the model. So it's a little bit of a subtracted definition there. But you have the model that is taking your user token input and producing an output. But tools like Claude Code and Codex, some more, some less popular tools like Pi or AMP, all of these are harnesses. They're programs that, of course, make API calls to the LM providers that produce outputs from these LMs given a user input. But there's so much more to these tools than just the model. Now, this is not a talk about harnesses. I just want to kind of lay the definition out there. So if I do mention it later, you're not confused what I mean. In brief, a harness is, as I said, everything around the model. It could be context injection, the prompt that you're using, the memory system that is like, trying to remember things for you, the way you've interacted with the tools, the skills you're using, or reusable prompts that you're invoking via slash commands, the conversation that you're having. It could be the actions that the model can take. Can it call bash? What tools can it use? What MCP servers does it have available to it? Could be how you observe and verify the model. That can it take screenshots? Does it see test results? How does it access logs from your program? Persistence, what file system is it using? Does it use Git? Does it, save its progress intermittently? And then also control, like when do you summarize the current context window and start a new context window? Do you use multiple agents at a time to kind of work on things in parallel? All of these capabilities are harness capabilities. And harness engineering is really just a subset of context engineering. Okay, it's the hooks, the commands, the subagents, MCPs, all the stuff that might implicitly inject context into your context window, where you as the human might explicitly inject context into the context window. So just as the final thing I'll say about harnesses is that, if you have these desired behaviors from the agent, you usually solve these problems by adding to the harness, right? If you want it to work with real data durably, you use version control. If you want it to write and execute code, you give it access to bash, right? If you want to complete long horizon work, you use things called Ralph loops and you make sure it constructs a plan first and it has access to ways it can verify whether or not what it's working on is correct. But each of these harness features derives from a behavior that you want the model to be able to do or perform, but that it can't do on its own. So the goals we have for these agents are that they work well in our code bases, they solve complex problems, there's no slop, or at least, a minimal amount of slop that's produced, and that we have mental alignment and understanding with what the agent is producing. We want to read the code. We want to know how the systems that we're building work, and this talk is going to tell you how to do that effectively. Okay, and then maybe a side goal is to spend as few tokens as possible, right? Because these are tools are costly. I think the cost for Opus 4.7 is something like $15 per million input tokens or $25 per million output tokens. So you can quickly rack up a high bill with using these tools. So we want to get there without a high bill, and we want to get to the place we want to go without being mired in slop. So the most naive way to work with a coding agent, let's say it's Claude Code or Codex or your favorite coding agent that you've downloaded and work with on a daily basis, is to just interact with it sequentially. Work until you run out of context. You see these kind of implicit things that are inserted in the context window. You send a message, it calls some tools, produces an output. You say, oh, no, it's not quite right. Then it does a few other tool calls. You interact, so okay, you're just kind of going sequentially. You're re-steering every time the LLM returns a result, and you're just kind of winging it, right, without any structure. The slightly smarter way to do this is that you start over versus just re-steering the agent, right? So let's assume that the agent did something and you were going to say, no, don't do it that way, do it this way. Well, instead of continuing, the same conversation, you realize that there's a misalignment there. And instead of populating your context window with the wrong information, you can say, oh, I didn't realize the model was going to go down this path. Let's start a fresh context and then extend my original message that says, okay, do this one thing, but make sure you use XYZ approach. This is the slightly smarter way, where you're kind of limiting the amount of redundant information that's in the context window, like here, where you just have all these steering messages and redundant tool calls if they weren't really on the right track. So the even smarter way to do this is to use a technique that we call intentional compaction. So let's say you have a session with one of these tools, and you get to a point where you're running up against the end of the context window, right? And you intentionally tell the model, hey, write everything we did so far to a markdown file. Ensure to note the approach that we're taking, the steps we've done so far, and the current failure we're working on. This is kind of a snapshot of the session you've been having that's condensed, contains all the relevant information and none of the irrelevant information. And then you put that into a new session and you begin working on it that way. It's slightly different from the previous approach because the previous approach was to not do steering in line, but this is actually an approach where you can maybe explore the topic. You know that you're not going to go down the right path initially, do a few, re-steerings, you figure out like the greater picture of what you're going to do, you summarize it, and then you inject that into a new session's context window so that the model can start off on the right track, going exactly the direction you want without any redundant information. So what are we compacting exactly? Well, we want to compact things like the file search output, which can be noisy, the code flow understanding, right? It may have done a bunch of research on your code base and needs to just distill what is the actual relevant information in your code base. So it doesn't attend to things that are in your code base that are irrelevant. What edits it made to files? That's usually not useful, like the full edit, diff, right? I mean, it's useful to know how you edited the file and which file you edited, but probably not the whole diff. Did you run any tests or did you build your project, right? All the output that your build tool produces is irrelevant to the next session, right? These JSON tool responses, you have custom tools that enable your sessions to go smoother and to have the LLM be more effective, but you don't really need all of the output of all those tools whenever you're starting a new session, right? So these are the types of things that we want to compact. But why does context matter? I mean, hopefully by now you're getting the general idea, right? Like context is efficacy. The less of the context window you're using, the more performant or the more accurate these models are going to be because they have exactly the information that they need and nothing less and nothing more, or at least as close as you can get to that. Context is actually everything, right? Because how do we use these tools? Well, we use them to make decisions, basically. And the way it makes decisions is based on the contents of the context window. So if you need to have the LLM that you're working with decide whether or not to edit a tool or rewrite the whole file, sorry, if it wants to edit a file or rewrite the whole file, it needs to have the right context, right? So it needs to determine the next step accurately. And so that's why you want to populate your context window with as the most correct information as possible. It all starts with the Claude MD file, actually, right? If you haven't heard about this, this is just a file that gets read on every invocation of every session, and it sets up the context. It says, this is the code base. These are the best practices to follow. If you need this information, use this tool. If you need to look at logs, of the production deployment, this is the name of the container that has those logs, that type of thing. But frontier thinking LLMs can only follow about 150 to 200 instructions with reasonable consistency. After that, they start to drop off in recall, and they stop following instructions. So this is about 12 to 18 months old, but you can see here as the number of instructions increases on the right, virtually every model falls off. Now, the state of the art back then fell off quite a little bit, quite a bit less precipitously as the smaller models did, but noticeably every single model falls off in instruction following capability. And so you need to write a good Claude MD. I mean, not only do you need to write a good Claude MD, you need to employ the context engineering practices I mentioned, but it kind of all starts from the system prompt effectively. And the system prompt is something that like a provider like Anthropic would inject automatically. So you don't even get to control that. But they're populating your context with something. And so you better control the context that's injected, starting with your Claude MD if you want to get the most out of these tools. So I'm not going to talk about how to write a good Claude MD. I'm just going to tell you that it's important. So I just showed you a graph of a bunch of different old models, maybe 2 years old, 2.5 years old, but actually these 1 million context window models are not that much better. They do not fall off as quickly. You can get to 128,000, 256,000 tokens with still 85% recall. In this slide, needle in a haystack is how well it can explicitly regurgitate something that exists in the context window. what is its success rate for doing that? And you can see past 256,000 tokens, it drops off immensely, right? And so this is not even considering the interaction that rules have with each other, right? This is just, can it recall facts? But often instructions have, it's a dependency graph, right? Instructions are not simply just like do A, then B, then C. They might be like if C, then D, else E, right? And so there's maybe this complicated instruction DAG that it needs to follow. And so in the best case, just explicit instruction recall, it falls off. You might imagine it falls off even more so in following complicated sequences of instructions. So this is why you need to preserve the context window. Once you get to 512,000 tokens, you may have said something back here to make sure you always do this, and then it just doesn't do it. And this is a problem, right? Because you would assume that everything you've told it has been remembered, but that's just simply not the case with the way these tools work. This is the most recent experiment somebody has run, and they tested all of the latest models, Claude Opus 4.7, GPT 5.5. They did something interesting here, which is number of constraint keywords. So it's kind of like instruction tokens, the number of tokens that make up an individual instruction. And so you can see that GPT 5.5 falls off at around 10,000. But if you imagine there's 10 instruction tokens per instruction, falls off around 1,000 instructions. But again, that doesn't even factor into play the interplay between the instruction that you're giving it, right? There may be some sort of complex control flow that you're telling it to do, which is not a good practice, but inevitably people use these tools this way. And that's how your conversation with the tool might go. And so I think I've, beating a dead horse at this point. Your context windows matter. As you start to fill them up, instruction following gets worse. So we want to optimize the context window for, in not necessarily this order, correctness, completeness, size, and trajectory. Trajectory being where are we going, right? We want to make sure that we're always kind of heading toward the ideal end state that we care about. To rank these problems, uh, incorrect information is the worst thing you can put in your context window, right? Because if it has the wrong information, it will certainly do the wrong thing. It's a little bit better, but not that good to have missing information because these models cannot act on information they don't have, right? It's just like a human, right? If you don't know something, you cannot act on it. And so finally, if you're going to try to get something wrong, if you have to, it's better to give more information than less, right? It's better to have more information than just not have relevant information at all. So this is the way you want to largely rank, when you're doing your context engineering. Um, Avoid at all costs incorrect information. Maybe you can handle a little bit of missing information, but and then a little bit more too much information. That is, you better err on the side of filling your context window rather than leaving out information or providing wrong information. You have an instruction budget. Skip this. Okay, so enter the dumb zone. I've kind of been hinting at it, or at least stating it explicitly, but not such in a pithy way. Uh, we call this the dumb zone. There's a threshold in which your context window fills up and your model like starts behaving poorly, right? Those were the kind of the asymptotes that I was showing in the graphs before. Roughly, this is 40 or 50% of the context window used, and we have a problem where when people start hooking up all these MCPs or all these custom tools into your environment, like maybe you have a Kubernetes MCP that talks to your cluster, or maybe you have a Google Drive MCP, right? And you have a Slack MCP, and you have all these interfaces, all these other tools, you can actually populate your context window just with tools before you ever do anything with the context window. This is problematic because empirically we've observed that the efficacy of these models starts to fall off dramatically after around 40 or 50%. 40% is a good gauge because like at least you can get a few interactions in before everything goes to crap. So with some of the models like GPT 5.5, you have about 200 tokens to work with. You have some auto compaction threshold that these model providers provide where they're going to automatically summarize your session and start a new one. They have some of the context windows reserved for output. And so roughly 100,000 tokens is where you want to kind of start thinking about whether or not you should start a new session. Models have been getting better recently, so I'd like to say 50% is a good guideline, 40%, it depends on your task complexity. Once you get to 50%, you have a small task you need to do, or like maybe you have a large task you need to do, so you want to populate the context to 40% before you start working. Not before you start working, but before you start considering starting a new session, is what I mean to say. So how do we avoid the dumb zone? Well, we do intentional compaction, which I mentioned before. The best way to do intentional compaction on the fly is to use subagents. Subagents are not for role playing, they're for context management, right? It's not that you want to say, you are a code reviewer, so go code review this code. You should be looking for X, Y. You don't need to give a role to the subagent. The utility of the subagent is that you're going to fork a process, basically, get a fresh context window, tell that agent to do something and produce an artifact, and then inject that artifact back into your context window, just like this. You send a user message, you say, hey, go find where XYZ is handled. You send off a sub agent, it gets a fresh context window, it does all the tool calls, it produces a result, and then injects only that result back into your context window. The file is at src/main. And now you've just saved however many tokens it took this subagent to use to arrive at this answer. All of this other stuff is redundant, right? It's searching, it's reading your code base, it's trying to figure out what is relevant. But what isn't relevant is not relevant to the original context window, right? So it's much better to do this type of exploration with subagents and inject a result back into your context window rather than just do everything in the single context window or even manual compaction, right? This doesn't warrant a new session. I mean, it does, but using subagents kind of builds this into the sequential flow of your conversation. So the ideal sub-agent response is something like this, right? Component usage flow, the modal path. This is the line of code in this module where this thing happens, right? Here are all the references of the files I used, right? And so your main Claude thread might look like this. Perform a slash command, call an agent with a prompt. It does a whole bunch of stuff, right? And then it produces the result. You call another sub-agent. And then maybe you're only at 50% context usage here, but you've done 3 million tokens worth of work, right? And so that's the utility of subagents here. So using subagents is one of the most effective ways to manage context in a single session, at least. Inevitably, you'll run out of space in the context window, even if you use subagents. So what do we do here when we have tasks that just inevitably are too complex to fit into a single context window? The answer is not to use more and more subagents and kind of shrink their responses more and more, such that eventually you're going to be omitting information at the expense of trying to save context. Remember the order in which we need to address these problems. Uh, less, not including information is worse than having too much information. So in this case, you're inevitably going to blow the context window. This I just had actually Gemini generate this image. I thought it was pretty funny. But anyway, I didn't really. It was close enough that I thought I'd include it in the slides, but it's not that useful. You're struggling, and then you're like, oh crap, compact, and then you kind of, and if you're not doing intentional compaction, you get in these scenarios where you're running out of context, and it's kind of too late. You kind of already went wrong because you weren't using subagents or you weren't doing intentional compaction. So what we want to do is frequent intentional compaction, not just intentional compaction, but we want to do this frequently. Actually, we want to build our entire workflow around context management. Roughly, you can break this down into three phases: research, plan, and implement. Okay. The goal is we want to stay in the smart zone for every session, for every interaction we have with the LLM. The research phase is going to work like this. We're going to understand how the system works. We're going to find all the relevant files, find all the relevant code blocks, and we're going to include just facts, no opinions. This is what the prompt might look like for research. You have some steps. Read any directly mentioned files first. Analyze and decompose the research question. Good research is comprised of facts. Bad research has facts plus opinions. So this is an example of what a good research agent invocation might look like, right? We have a state machine it finds, right? It has a database schema. It's coming up with all of the relevant things related to the task at hand. You might, talking about opinions here, right? Oftentimes you'll say, I'm going to go implement this feature. Go look at the code base. to figure out what parts of the code base are relevant, right? And it might come back and say, oh, here's the things that are relevant. We should implement the feature like this. No, we don't want to conflate engineering with research or implementation details with research. So we want to make sure research comes back with just facts. For the plan phase, we want to outline the exact implementation steps, including the file names, lines, and code snippets. And we want to be explicit about how to test whether or not the code is correct. A plan might be 85 instructions or so. Or sorry, the plan command to tell it how to write the plan might be 85 instructions or so. And this is a good example again of why we're using a single context window to do each of these steps. Research gets its own context window. Planning gets its own context window. Implementation gets its own context window because we only have a few hundred instruction budget. And if we tell the agent to make a plan, we may exhaust 85 instructions for the plan instructions itself, plus the Claude MD, plus the system prompt, plus the tools it has, etc. Right? And so quickly you run out of room in your context window to do any meaningful work. And this is just kind of hammering home why we want to segregate these phases of our um, task completion efforts. So the wrong way to make a plan would probably be like this. You have your ticket, you have your research, it launches some subagents, and then you start talking with the talking with the agent, and the agent is interviewing you. Question one, question two, phase one, and you're doing a review in line, and you're kind of bloating the context window, and you finally get this plan after like the series of interactions. The better way is to just have a bunch of subagent calls and then write the plan, right? Because your answer, option A and B, maybe you chose C. A and B are redundant. Option B and C here are redundant if you chose A, right? So we're trying to avoid this style of like interview me about these things. We want that to happen in a subagent. So the subagent makes the decision and then injects the result back into the context. And then we write the plan. And this way, the main Claude thread or Codex thread is going to be focused primarily on constructing the plan and not about all the redundant information that you might expose while you're working with the agent to build the plan. Good plans are phase ordered, vertically sliced, and explicit. I'll talk about a bit about vertically slicing the plans in a sec. Many of you have probably seen something like this before. You ask the agent to make a plan. It says, oh, I'm going to do all the database work first, and then I'm going to define the services, and then I'm going to build the API, and then I'm going to build the front end, right? And it kind of does this phase at a time. But now you end up with this monolithic app that hasn't been tested at any point. Maybe you test the database layer on its own, but you really cared about the database layer for a front end feature. And you end up with like this giant, few thousand lines of code to try to test all at once and figure out what went wrong where. A much better approach is to use vertical plans, where you kind of design these vertical slices, right? You might have heard this before, like make it work, make it right, make it fast, right? So this is the make it work part. Usually the way we do this is by making an end-to-end flow of some simple feature, and we kind of build outwards, right? Horizontal plans are bad. Vertical plans are good. So this is going to be part of our instructions we give to the agent when we want to when we enter into the plan phase. And finally, we have the implementation phase. This is the place where we go and write the code. If we have a good plan, the implementation is easy and expected, right? The plan is where we should spend most of our time interacting with the agent, getting alignment, figuring out what we want. And then if we have alignment on the plan, you can just say go implement the plan and you read the code afterwards and see if if there was any deviations from the plan. But the whole time, when we're implementing phase by phase of the plan, we always want to keep context under 50%. This means we want to use subagents heavily. We want to make sure that the phases of the plan are small enough that they can be implemented in a context window. This is an example of, the instructions you might give to the agent to do the implementation. But after all this, please read the code. We're still at a space where we need to read the code. You achieved shared alignment and shared understanding of what you wanted to do with the agent in the plan mode, but inevitably there are implementation details. So you still need to review the code. Even though you got alignment on the plan, you need to look at the output to make sure that the architecture of the code is correct. Did what you expected to be implemented get implemented, or was there a deviation from the plan that was unexpected? Right? Maybe that means you need to scrap that code and go back to the plan, have an answer for that thing that wasn't explicitly specified, and then tell the agent to go do it again. We cannot outsource the thinking. Okay, these models are good at generating code, but we still have to think about what we want to do, right? This is a quote from Jake Nations. He gave a presentation at AI Engineer. He's a Netflix engineer. Uh, and he says, the hard work of thinking can't be outsourced to AI, only amplified by it. The agents help us work faster and better, but only if we supply the creative aspect of this process. So some of you might be wondering, isn't this just spec-driven development? And it kind of is, but uh, this term is overloaded, spec-driven development, like a lot of things in industry, like the word harness, right? Or agent. So some people might consider spec-driven development as writing a PRD, and others might say it's treating spec-driven development is treating the code like assembly language, where you don't read the code at all because you're so focused on getting the spec right that obviously the code is going to be correct. And none of this is quite right, you know. So spec-driven development is basically, semantically diffused or otherwise not really well agreed upon the definition of. What do we need? Well, we need this process, research, plan, implement. Research is effectively compression of information, right? Compression of truth. Like go out, look at how things are, and bring me back the facts. And planning is leverage. We can gain leverage over a successful implementation or over the model if we achieve alignment, right? That's what the planning phase is for, is achieving alignment with the agent, with what we want to do and how we want to do it. Don't outsource the thinking. We need to be wary of token burning slot machines. Some people are running, dozen agents in parallel. The bottleneck is still us. There's no way you can review 12 agents of output, or kind of engage in this research plan implement behavior with all 10, 12 of those agents. It just doesn't work. So research is compression. We need to understand how the system works. We need to find all the relevant files, and we need to stay objective. Every time we do work, agents need to be onboarded. Somebody had this funny tweet recently. It says the best movie on context engineering is Memento, right? Like agents every new agent needs a history of like what's happened, right? And that's what this research phase is. Because if they don't do that, they start to hallucinate. I don't know how many of you have experienced this. You say like, are you sure about that? I think it's this way. And the agent says, oh, absolutely right. You need to start a new context window if you hear that or if you read that. So what we're going to talk about is how research works, right? So assume this is our code base, and we say, all right, we want to do some work over here in this, subdirectory. You might first say, well, what if we took all the information, we have a bunch of repos, we're going to do some cross repo work. We take all this information across these repos, we compress it into like a markdown file that's at the top of these repos. The problem with that is sometimes you miss some things. Sometimes those markdown files are too long, and sometimes they're just incorrect, right? As you modify code in these subsections, maintaining, the state of these markdown files that tell you how the code works is just, problematic. We've all experienced this. Documentation goes stale, it gets incorrect. It's the same problem here with agents. So this is an example of how you might like do a bunch of, compression here, and then you're starting every context window with just this huge block of information about how the system, works. How does your code base work? So what's better is we need to do progressive disclosure. Instead of doing docs in every directory, uh, well, one thing you could do is, so I got ahead of myself, but one thing you could do is have docs in every directory instead of just one giant summary at the top. And that way, the repo documentation is one level of abstraction. Then you get into products and expertise areas. Those are at a different level, and you kind of go down until you're at the files, and you don't document the files because code is the truth. And this is how it might look. As your agent kind of searches down, they read the repo context, then they read the product context, module context, directory context. And this kind of works, but it still has the same issue. Whenever you ship new functionality, you kind of have to do this like backwards tree traversal, this backtracking and updating all the docs at every layer, and that doesn't work either. So you could make it a part of your PR merge process to update this, but this is too complicated. And as we all know, the amount of lies as you get further away from the code increases. So the best approach is actually on-demand compressed context. So what we want to do is every time we want to tell the agent to do the research on its own. We want it to launch some sub-agents, and then we want to write a research output. And all this happens in one context window, right? This is how we effectively do research. Sub-agents with exploration patterns that then report all the relevant information back into the parent agent that then writes the research document. We want to keep things objective. We don't want to do any implementation planning here. Research is only the compression of truth. So planning is the leverage part of it. We compress what we want to do into explicit sequence of things that we should do. The plan, this is like a slash command. It's just a reusable prompt that tells the agent how to produce a plan. You have some, PRD, some ticket, some bug report, along with the research. Those are the inputs. And then it comes up with the plan. And then you iterate with the model on the plan until it produces this plan file. Each phase of these things should be executed by a subagent. Each subagent should, oh, sorry, when we're implementing the result of the plan, as I mentioned before, we should implement the phases sequentially, and every phase should be implemented by a subagent so as not to pollute the context of the main agent. Each subagent should commit its changes, so we have a history of what changes happened and in what order, and then each commit should be independently testable. Our goal here is mental alignment. Okay, that's how we get the leverage from the plan, is we make sure we know what the agent is going to do and how it's going to do it. So what is code review for in this whole scheme of things? Well, code review, the most important thing is again mental alignment, right? We had mental alignment with the plan, but then we need to read the code and make sure that there was no deviations and we got out from the model what we wanted. But reading thousands of lines of code each week is hard. But reading 300 lines of an implementation plan makes it easier because at least you have some coherent, structured knowledge of what the code should be doing. So if you read these 300 lines first before you review the code, you can kind of skim the code and not do as, you don't have to give it as thorough of a review versus if you just gave the agent like 3 sentences and said, go do this complex feature, right? Because we've achieved mental alignment with the plan process. If the plans are good, that's nearly enough for code review. We want to catch misalignment early, and we want to maintain the system understanding of what we're building. Please read the code. We are not yet at a point where we cannot read the code. So the goal of all this, right, is leverage. And I know I'm being a little redundant here because there's a lot of information, but I just want to keep revisiting the main points of this talk. You want high confidence the model will do the right thing. And checkboxes in a plan are not enough, right? You can look at all these checkboxes and like, wow, this is a well-specified plan. If the model does all those checkboxes, surely it's going to be correct, right? And it even has the code here. When you want the plan to be, a compression of the intent that you want to do, such that there is, or the intent that you have for the feature of the bug report, such that it can reliably execute on what you're asking. But there's a sweet spot, right? You can't have a 2,000 line plan. Now you can't review that either. And so there is some kind of sweet spot between how readable the plan is and how reliable you are, how much reliability you're going to have when the agent actually implements it. We review the research and the plans to achieve mental alignment. Do not outsource the thinking. This is not magic. You still have to read the plan. You still have to read the code. So this is putting it all together. This is what it might look like. You have your research session. You invoke your research code base skill. You do a bunch of subagent tasks. You write the research artifact. You inject that research artifact into your planning phase. You iterate with the model. It does some tasks with subagents, produces the plan. Then you inject that plan into the implementation context window, and you use subagents to invoke the phases of the plan, or sorry, to implement the phases of the plan. Here's a different view of it. You want to have human in the loop at all phases, right? You might even review the research document because you think that your code base is confusing and maybe the model is going to think that one part of the code base is relevant, but it's really not. Maybe there's a duplication of microservices at your startup or whatever. So at all phases, I'm advocating for human in the loop. Do not let the agents do this on their own. You need to review all the artifact outputs. Our goal is leverage. This is the hierarchy of leverage. As we go up the levels of abstraction, it's more and more important that we have the right information. One bad line of your system prompt or your Claude MD can produce potentially 100,000 lines of bad code, right? Because it's like the very first instructions every single session you enter into is going to have. But at the end of the day, one bad line of code is one bad line of code, right? So we want to have leverage. We want to work at higher levels of abstraction to achieve mental alignment and have the agents do what we want. A little bit of bad research produces a lot of more bad plan, and bad plan produces a lot of bad code. So we need to make sure the research is right. We need to make sure the plan is right so that we can have confidence that the code is right. But is all of this overkill sometimes? The answer is yes. Sometimes just talk to Claude. Small fixes, small bugs, whatever. Don't invest in this. This is more like if you think the output is going to be a few hundred lines of code, this is the process I would engage in. If you think it's a dozen or so, just talk to Claude. Make a simple plan and then tell it to do it. People are calling this RPI, Research Plan Implement, but it's actually a little bit more complicated than this. People are reporting 2 to 3x productivity, but obviously all this is kind of in its infancy. I know personally, I use this workflow for probably 80% of the work I do. Sometimes I do some explore sessions before to kind of get a good handle on the problem, and then I enter into research plan implement. But I would say very easily, I'm getting at least 2 to 3 days of work done in one day, all the time, every single day. Some days, 4 or 5 days. Other days on a particularly hard problem, I don't make any progress, but that's just natural. Let's skip this. But actually, research plan and implement is probably not the most optimal version of this. There's a lot of other phases you could enter into, and you have this, you can iterate on research questions before you actually do the research, and this is probably more like the actual workflow I use, but I figured going through this was going to be too much information for a 40-minute presentation. And I'm already over a little bit over time, but I just want to show you that this is just the beginning. I know it felt like there's a lot of information, but there's a right way to use these tools. There's a right way to get the most out of these tools. And it kind of looks more something like this and not just RPI that I've described before. And just so that there's some time for questions, I'm going to go ahead and say thank you for coming to my talk. Uh, Please read the code. And finally, I want to give a big thanks to Human Layer. This is a company that I'm working with. They build a product that makes this workflow a lot easier. They have no affiliation with them other than I use their tool. It makes my life way better. They produced a lot of the slides for this talk. I asked them for their permission. I reused a lot of their Excalidraw documents. And yeah, with that, here's my contact info, and I'd love to take some questions if anybody has them.
Thank you, Thomas. I think this is really useful, really important, and really at the guts of what people should be doing. We can open up for questions both on meeting chat and also we can open up mic and ask. So I guess I get to ask the first question and actually a little bit of a request. Uh, you talk about sub agents and Claude.md file and a lot of things in a little bit of abstract. Is it possible for you to give us an exact script of some of these things and I can add to the with the include with the talk? So by the way,
Yeah.
I will put in chat. I am going to put the website that we will put all the video and the slides. So you can add that to the slide, Thomas, if you want, like some like exact things, like how do you what you should need to type into Claude
Yeah.
or what do you edit the file, and so people have a little bit of concrete information. With that, I will open up for questions. I'm going to put the thing in the chat. Go for it. There are couple of questions on chat.
Yeah, I
Thomas,
see
you can
them.
see them. You can answer them. Go for it.
Yeah. I will definitely share the slides. So yeah, these are not proprietary in any means. How do I apply this flow to debugging existing code? I do this all the time. For example, let's say you get some cryptic error in production, you want your agent to maximally effective in helping you debug. This is related to harness engineering. I'm gonna try to give like a 1 minute answer. It's more complicated than that, but harness engineering means partially giving your agent the tools to work on your code base. So for instance, at work, I have a Kubernetes cluster that I deploy my services to. Okay. When a container dies, like it gets killed for some reason, and I want to know why. What we have at my company is we have a Kubernetes MCP. So we have a tool that the agent can use to read the logs of the running container in the cloud. And so I say, I don't have to know you know, I don't even need to know how to access Kubernetes. I just say, here's the container that crashed. Why did it crash? And then it has the ability, it has the API access to the Kubernetes logs to figure it out. And then it'll tell me why. But so let's say there's a more complicated failure where like Kubernetes crashes, but also, you need to tell somebody about it on Slack, and it's actually related to this bug ticket in linear. If you expose all those MCPs to your agent, which is a bit of work, they don't just come for free. Uh, your agent has the ability to do all of that. It can read the Kubernetes logs. It can then look for relevant tickets in linear, and then it can post the Slack to your, team channel that says, here's the diagnosis of that bug. So that's an example of how you help it debug existing code in production or even just in, beta testing or whatever. Second question, are there any harnesses which help with this RPI style flow, or is everyone on their own every time? I mentioned here, Human Layer is a company that builds a product called Riptide, and it's an IDE that bakes all this, actually QRSPI. This is more like questions, research, design, structure, plan, work tree, implement, pull request. Sounds like a mouthful. It's actually just like the right workflow you should use to do complicated work. Every one of these is a new context window. Every one of these is human in the loop. You do a design, not just a plan, because during the design process, you don't care about the ordering of phases, right? You just care about, are my data structures correct? Are my APIs correct? Are my interfaces between modules correct? That type of thing. And the plan is more like, what are the exact steps we're going to do in what order to accomplish that goal? And so I will also share a link to that beta. I'm going to ask them first. They're kind of in like a closed beta, like the link is public, but not really. So if y'all would love to try that out, I'll ask for their permission to share that. But the answer in short is yes, but not many. Most people are more like YOLOing it right now. Next question. An underlying assumption is that the human knows the right answer most of the time. How does this change when the human knows very little? Yeah, unfortunately, you have to have a higher budget for slop in that case. I mean, there's a certain amount of trust that you need to give to the agent. It will hallucinate, right? But is the saving of the time that you get from using the agent and dealing with some of its sometimes incorrect information better than spending hours on your own to research the space and draw your own conclusions? You will also hallucinate, actually. You will also misremember. You will misunderstand something, right? So I think no, we don't assume that the human always knows the right answer.
I think one thing I'll add is if you create a good testing harness, you might not understand the middle, but if you understand the input output, you can create a good testing harness and sometimes get away with it.
Exactly. And that's actually part of harness engineering.
Yeah.
Testing harness is actually the word is in there, preceded the word harness engineering, right? Like if you give a model the way to check itself and to like verify whether or not what it's done is correct, that's huge leverage. Absolutely. That's huge impact. I think we got time for like one or two more questions.
Yeah.
Are there tools that people use to improve prompts you put into agents? Okay, I'm gonna have a hot take here. Prompt engineering doesn't matter. Your prompts don't matter. Talk to these agents how you would talk to a human. Okay. The important part is the workflow, right? They start getting dumb when they pass a certain threshold. They stop being able to recall things. You can think about this as like leaving information out. If the agent can't recall it, it's basically like you left information out. And remember, that's bad, which is why you want to keep these sessions kind of low. There is no magic prompt. There are no magic prompting techniques other than like be explicit, right? So the more vague the prompt you have, the less you're going to get out of the agent. The more specific you are, the better it's going to know exactly what you want to do and how you want to do it. And then also human in the loop, iterate with these tools. So the final thing is that Saman, and I'll address this. You asked me, can I include like a link to some examples of these things? In this slide here, this is a treasure trove of examples of these things. This is human layers repo. These are commands for Claude. I'm sure they could be repurposed to Codex, but you can see here the create plan markdown file. If you copy this markdown file to .claude/commands, you can invoke create plan with a slash command, /create plan, and then tell it what you want to create a plan for. And this is a few hundred line markdown file with like 100, 85 instructions that they have worked on for, a long while, and this is a great starting place. I wouldn't recommend these verbatim. You should open them up, you should read them and make modifications so that it suits your workflow and how you want the agent to do a plan yourself. But this has all of the foundational like ideas about uh, how you should write these instructions for the agents to follow to implement research plan and implement and help you achieve the productivity gains that these frontier model companies promise.
Okay, I think we are up to time. Thank you so much.